In this tutorial, we're going to take a look at the meaning of a negative exponent and also the zero exponent. And I'm going to start with this table which has to do with the metric system. It's a lot of the common prefixes in the metric system, and use the multiples of 10 here or powers of 10 as an example of what a negative exponent means, what a zero exponent means. So we're going to talk about both of those. A kilometer, so we have meter right in the middle here, 1 meter. Kilo means 1,000. So there's 1,000 meters in a kilometer. So what we're going to do is, for the hectometer, there's 100 meters in a hectometer. A decameter has 10 meters in it. And then we have the smaller prefixes here. A decimeter is 0.1 meters, a centimeter is 0.01 meters, and a millimeter is 0.001 meters. And if you go from this number to this one, notice what we're doing is, actually, I'll bring my calculator over here, is we're dividing by 10. So if I take that 1,000 and divide it by 10, I get this 100. If I take this 100, divide it by 10, I get this 10 here. Divide 10, divided by 10, that gives me the 1 where the meter is. And if I take this 1 and divide it by 10, I get the 0.1, and then 0.1 divided by 10, we may as well go all the way down the table, is the 0.01. And the millimeter, if I take the 0.01, that one, divided by 10, say I get 0.001, the millimeter one. So the what we're going to do is write all these as powers of 10. So 1,000 is 10 raised to the exponent 3. Remember, and I'm really bad for saying this incorrectly, the whole thing is a power. We would call this the third power of 10. The 3 is actually the exponent. So this is 10 raised to the exponent 3. A lot of people say 10 raised to the power of 3, but technically the 3 is called an exponent. The whole thing's a power. So just to show you here, 10 times 10 times 10, there's 1,000. 100 is 10 squared. See, it's 10 times 10, or 10 squared. So this is 10 squared here. 10 is the same as 10 raised to the exponent 1. And so I showed you as we went down the table here, I'm dividing by 10. So 1,000 divided by 10 is 100. 100 divided by 10 is 10. 10 divided by 10 is 1. So notice what's happening to the powers of 10 is as I divide by 10, or 10 to raise to the exponent of 1, I'm subtracting 1 from the exponent each time. So the 3 becomes 2, the 2 becomes 1. So now we're going to talk about the zero exponent for a moment here. So this should be 10 to the exponent 0. So now these are all equivalent. 10 cubed is 1,000, 10 squared is 100. See, 10 raised to the exponent 0 would equal 1. The exponent of 0 is always equal to 1. It doesn't matter what the base is. If I want to put a 3 here, 3 to the power exponent 0 is 1. If I want to write 17,253 raised to the exponent 0, it's also 1. Doesn't matter what number you put in place of the base. Except you can't raise 0 to the exponent of 0. Notice my calculator won't like that. It gives me an error. Okay, so I can't evaluate that. It doesn't like. It's actually because you're dividing by 0. That's the reason you can't do that. I'll talk about that just a little bit in the next page. So as I divide by 10 here, 10 to the exponent 0 divided by 10. So we would subtract 1 from the exponent again. So the 0 becomes a negative 1. So 0.1 is the same as 10 raised to the exponent negative 1. When I subtract 1 again, I get 10 to the exponent negative 2. So 10 to the negative 2 is 0.01. So that's the decimal equivalent. That's written as a power of 10. And then do it one more time. 10 to the exponent negative 3 is 0.001. Now, let's talk about the negative exponents here. A negative exponent, what exactly does it mean? It is actually the same as a reciprocal. See, 10 raised to the exponent negative 1 is the same as 1 over 10. Remember, to go from this number to this number divided by 10, 1 divided by 10 was 0.1. So 1 divided by 10 is the same as 10 to the power to the exponent negative 1. This one here, 10 to the power of negative 2. So we divide it by 10 again, and see, when you divide by 10, it's the same as multiplying by 1 over 10. That's the same thing as dividing by 10. So 1 times 1 is this 1 here in the numerator. 10 times 10 is 10 squared in the denominator. So you see, if I take this and divide it by 10 or multiply it by 1 over 10, 1 times 1 is 1. 10 squared times another 10 is 10 to the third. Just remember, you add the exponent. There's actually 3 tens in that product. So that's what a negative exponent means. It means they're reciprocal. So 10 to the exponent negative 3 is the same as 1 over 10 cubed, or 1 over 10 raised to the exponent 3. Let's move on to the next page here. So zero exponents. Now, I don't have to use a base of 2. I could use any number whatsoever. So I've got 2 different examples here. One uses a base of 2, the other one uses 6. There's no particular numbers. Reason I used 2 and 6, I could have used any number I wanted. So what I'm going to do is I'm going to evaluate this 2 different ways. So one way is I've got 2 to the exponent 4 divided by 2 to the exponent 4. So I'm dividing the same thing by itself. And whenever you divide something by itself, you get 1. See, it doesn't matter what number. 2 raised to the exponent 4 is actually 16. So this is actually 16 divided by 16, which of course gives you 1. Now another way to evaluate this is, and you're going to see the same thing come up here. So we're going to take 2 to the exponent 4 and divide it by 2 to the exponent 4 again. And if you remember from some algebra with powers of the same base, another way to evaluate this is to keep the base of 2 and then subtract the exponent. See, this 4, there's that 4, minus this 4. 4 minus 4 is 0. So this is actually the same as 2 raised to the exponent 0. Now I evaluated the same thing, just 2 different ways. I got 1 over here. I got 2 raised to the exponent 0 here. So 2 to the exponent 0 and 1 must be the same thing. Like we had 10 raised to the exponent 0 equaled 1 on the previous page. 2 raised to the exponent 0 is 1 as well. In fact, it doesn't matter what number I have in the base. See, I could put 3 raised to the exponent 0, tells me is 1. 742 raised to the exponent 0 gives me 1. It doesn't matter what number's in the base. So now the negative exponents. So I've got 6 raised to the exponent 3 divided by 6 to the 5th. And again, I'm going to evaluate this 2 different ways. One way is I'm going to write out all the powers as products of, in this case, 6, because the base is 6. So 6 cubed means 6 times 6 times 6. There's 3 of them there. And 6 to the 5th means there's 5 6's multiplied. Now in every single case here, so what I'm going to do is I'm going to divide, it's called dividing out. I'm going to take this 6 and divide it by this one. There's no particular reason I did those 2. I could have taken this and divided by this, or this divided by this. But 6 divided by 6, okay, again, a number divided by itself is 1. What you'll see a lot of people do when they're dividing these is they'll write this, okay? So they'll write 6 goes into 6 once. My pen wasn't working right. And they'll put a 1 here. 6 goes into this 6 1. So I've actually still got a 1 here I'm multiplying. And then again, this 6 is going to divide by this 6. Okay, 6 goes into 6 once, and 6 goes into 6 once. So there's still a 1 there. And then one more time, 6 goes into this 6, dividing once, and 6 divides into this 6 once. So in the numerator, what I still have up here is 1 times 1 times 1. So there's actually still a 1 on the top. in the numerator. And in the denominator, I have 6 times 6 times 1 times 1 times 1. Now, 1 times 1 times 1 is all 1. So it's really just the product of 6 and 6 here in the denominator. And 6 times 6 is the same as 6 squared. Now, I could evaluate that and write as 1 over 36, but I want to show what these the relationship for negative exponents and powers is. Now, another way to evaluate the same thing, notice I have the same thing here, is by what we did up here. Both these powers have the same base, it's 6. So I can evaluate this by keeping my common base of 6 and subtracting exponents. 3 minus 5 is what I'm going to do with the exponents, and 3 minus 5 is negative 2. Now, I evaluate the same thing just two different ways, so this and this must be the same. So 6 raised to the exponent negative 2 is the same as 1 over 6 raised to the exponent of positive 2. So that's what a negative exponent means. Again, it means a reciprocal. Reciprocal means it's 1 over the same power but with a exponent that's positive. Now, in general, it doesn't matter what number's in that base. I'm going to call the base a number A. I don't want to just always use a number like 6 or 2 or 10 or 3. So if you have, if I call the base A could be any number whatsoever. A raised to the exponent negative n is equal to 1 over a to the power of exponent positive n. Again, the number a in the base can't be 0, just like I can't go 1 divided by 0 raised to any exponent. If I put 3 or something like that. See, I'm actually dividing 1 by 0 here. That's why the calculator doesn't like it. I cannot do that. So let's take a look at simplifying some numerical expressions with negative exponents. So the 4 raised to the exponent negative 3. That would be the same as 1 over 4 raised to the power of exponent positive 3. So again, that's the reciprocal part that I was talking about. And so what I would do now, just to simplify this, is I'd evaluate 4 to the exponent 3. So that's actually 64. So this is 1 over 64. So 4 raised to the exponent negative 3 is the same as 1 over 64. We would generally evaluate this power and not just leave it as 4 cubed. B here. Now, B and C are kind of similar. The brackets is the difference, and I want to show you what the difference is between those. So very similar to A here. This would be the same as, again, because the exponent's negative, it's 1 over what's in the base here, the negative 5, raised to the power of, exponent of positive 2. Okay, so and I would evaluate my negative 5 squared. So negative 5 in brackets squared means negative 5 times negative 5, which is positive 25. So this is actually 1 over 25 here. Now, the brackets means that it's negative 5 that's being raised to the exponent 2 here. What's different in C is that there's no brackets. If I were to write brackets in the appropriate place here in C, the brackets would be just around 5. Okay, if you really wanted to write them. So this is actually, and I didn't mean both those to come up, there's a negative out front. The negative has nothing to do with this exponent of negative 2, this negative in front here. So we have to, it's really actually bed mass. We have to evaluate exponents. Remember, bed mass, there aren't really any brackets here, so we're doing the exponents first. So we're doing 5 to the power exponent negative 2, which is 1 over 5 squared, and then it's negative, this negative out front here. So we would evaluate 5 to the exponent of 2, which is 25, it's 5 times 5. So it's 1/25, and then this makes it negative here. So notice that the negative being out front here, and again, you don't have to write those brackets around the 5. because there's no brackets around this like this one, the negative isn't in here or the 5 in this one. It's out front, just meaning that the answer is going to be negative. So if the negative's out front with no brackets around it, then you're going to get a negative whatever that fraction is. In D here, I'm going to show you 2 ways to do D. I'm going to do D like I did A, B, and C, and then I'm going to show you a shortcut. So the exponent of negative 3 is what the 2/5 is raised to, so we could write it as 1 over the 2/5 raised to the exponent of 3. So this exponent of 3 means we're going to cube the 2/5. So now what I'm going to do is dividing, and I actually could evaluate this power of 3 here first, okay? But this dividing, we've got the 1 here, and we're going to multiply by, the way you divide is you multiply by the reciprocal. So it's going to be 1 times, and the reciprocal of 2/5 cubed is 5/2 cubed. Notice I took the reciprocal of the 2/5. And so now what I need to do is evaluate 5 cubed on top and 2 cubed in the denominator. And so 5 cubed, or 5 times 5 times 5 is 125, and 2 cubed, or 2 times 2 is 8. And actually, let me bring the calculator back here just to show you that. So 5 raised to the exponent 3 is 125 in the numerator, and 2 raised to the exponent 3 is 8 in the denominator. So that's where the 125 over 8 comes from. Now, I said I was going to show you a shortcut for this one, so I'm going to write the question down again. Now, the negative exponent means the reciprocal. So this is actually the same as take the reciprocal of the 2/5, which is 5/2, and it's now raised to the exponent of positive 3. Okay, so you see here I wrote the reciprocal as 1 over, but you can also write it as the reciprocal of the fraction. Okay, 2/5 reciprocal is 5/2. When I take that reciprocal, the exponent changes sign. So now I just have, I'm really here already, and I just have to cube the 5 and cube the 2 and get 125 over 8, and we're done. Okay, so when you have a fraction to an exponent, that's what you can do. So for example, just one other example, let's say the fraction was, let's say 3 over, well, let's say 7 to the power of negative 2, for example. So that's actually the same as, I can take the reciprocal of my fraction, okay, 7/3, and it's now raised to the exponent positive 2. So in the numerator, 7 squared would be 49, and the denominator 3 squared would be 9. So it's actually 49/9. So that's, again, if you have a fraction raised to an exponent that's negative, that's a little shortcut to a way to do that. And that's the end of the tutorial.